Welcome back, everybody. I hope everyone that's in the US had a great Thanksgiving. Today we have a really good video, and I think this is something that could help with most everybody, but I think is really going to cater to those that are in the early stages of their career. And that's talking about the scientific journey. So what are the stages? If you're somebody coming from undergrad, what is grad school, the difference between a PhD and a master's? What is this thing of a postdoc that you hear about? What are the career opportunities that you have afterwards? Let's dive into all this. Let's talk about, what is a scientific career journey for a beginner? Let's just lay it out there. So if you're watching this, you're probably at least in undergrad right now doing science and thinking about, what can my next career step be? So of course, a lot of us go into undergrad into science thinking about things like medicine or nursing or being a dentist or a vet, something like that, something in the medical profession. However, you do have the opportunity to pursue science as science. So with that, you could do one of two things. You could either go get a master's degree or a PhD. So let's talk about first the differences between the master's degree and the PhD. So let's start with the master's. There's really two types of master's that you could get. There's a research thesis-based master's and a non-thesis master's. So what's the difference? So the non-thesis master's is the closest that you're going to get to undergrad. Essentially what it is after you're done with undergrad, you'll be able to either, right after you're done or sometime in the future, online or something, take X amount of credits towards getting a master's degree. And that's it. There's no lab work or anything else. It's just you take some classes and then you're done. Now, the amount of credits that you're going to take are going to depend, but you're really going to be taking the core competencies. So things like genetics and maybe biochemistry, cell biology, things like that. If you're a chemist, there's going to be core chemistry, things like organic, inorganic, physical chemistry, whatever they are. And after you're done, you'll get your grade and then you'll get your diploma. You'll be a master's in biology or chemistry or whatever it is. Now, for an exact same diploma, you could do something called a thesis-based degree, which essentially means that you have to take those core classes, but then you also have to perform some level of research and write a thesis on it. So a typical master's degree that's non-thesis based maybe is going to take 1.5 to 2 years to complete. Whereas a thesis-based master's degree is going to take about 3 years to complete, maybe 3.5 years. And the biggest difference really is the time it takes to actually do that research. Now, which one do I recommend doing? It depends. So if you're somebody that has been out of school for a while, you're working and you just want to advance your career, maybe it's worth on the side doing the non-thesis option master's degree. So, you've been out of school for 15 years and you realize that you want to move up a little bit higher, get a little bump in pay. So you want to get a master's degree on the side while you're working, do the non-thesis. If you're coming right out of school, you're probably going to want to do that thesis-based option. And the reason is that once you're done, you're going to be able to be set up for working in a lab. You actually have built some lab experience. And that's really important when someone's trying to hire you, to be able to demonstrate that you could do X, Y, or Z within a lab. That's actually a really important skill, maybe even more important than the classes that you take. So that's something that you really should consider. Now, if you're a bachelor's or a master's degree, what are your kind of career options, if you will? The bachelor's degree is going to have maybe the smallest choice. So with a bachelor's degree, you could go work in industry. You could go right out of your bachelor's degree, go start working in industry. There are positions in government. So for something like the FDA or CDC, there's positions available at the NIH. There's positions available in academic labs that you could go to, like a lab tech. So there's options out there for you. Now, getting your master's degree is going to open up more options for you. So if you get your master's degree, now you've put yourself in a position where if you go into industry, you could get a little bit higher of a title and pay, some more responsibility. You could again go into an academic lab. If you go into working for the government or something, maybe you could get a little bit of a better position, but that's sort of where you're gonna go. The difference between the bachelor's and master's in terms of pay is actually fairly substantial. There may be even a bigger jump between the bachelor's and master's than there is between a master's and PhD, at least at first. Over time, the PhD will outperform, but up front, maybe the difference isn't quite as big. But this is something that you should consider. Now, the next option is a PhD. So first of all, do you need a master's in order to get a PhD? There's really two schools of thought. There are some programs that think that a master's degree or some level of working in a lab, maybe in industry or something, after you're done is gonna help, and they wanna see that before they would admit you for a PhD. And there are people that have that school of thought. Now, I've also talked to some other people that are on admissions committees that say the opposite, that they think that the best candidates are the ones that are, coming right out of undergrad, did really well in undergrad, know what they want, and go in to the PhD. And they think that the people that did a master's maybe are people that really can't quite figure out what they want in their future. And so they're not as likely to take them. So there really isn't a one size, shoe fits all. It's probably gonna depend on the type of program and who's on that admission committee. So it's hard to give a real concrete answer to that. However, what you can do is either after your bachelor's or your master's is you could go for a PhD. Now, how is a PhD different than a master's? So at first, it's gonna be the same. So what you're gonna be doing is you're gonna be taking classes on core competencies. The difference is that will end for a master's, whereas a PhD will go on to take even more advanced classes that are specialized for the type of research you're doing. So if you're in a immunology lab, you're gonna be taking some very hardcore immunology coursework. If you're somebody like me that was in physiology, I took some very hardcore physiology work. Some of it was directly done with my PI, who would teach the physiology to me. So you're gonna be going really in depth in a very specific area. So that's the first difference. The second difference is that unlike a master's degree, you're gonna have something called qualifying exams or preliminary exams, or prelims, quals, prelims. Sometimes you even have both. But what those are basically a weed out. It's every place is gonna have it set up differently, but it's gonna be a mixture of oral questions and written questions, and the questions are gonna be about your own research. They're gonna be about the coursework that you took, or just about science at large. So I've seen qualifying questions like write a grant proposal for X, or very open-ended questions. And what it's meant to do is to decide if the committee that you have that's overseeing your PhD work thinks that you are ready to move on to the final stages of doing your degree. And there are people that don't pass this, that literally they don't pass, and what ends up happening is they leave with a master's degree. Now every school handles this differently, and so again, you can't really make a blanket statement about how qualifying exams are. If you want, I could always make a separate video dedicated to qualifying exams, because this is a real huge part of your degree, and it is really intense. So let me know in the comments below if you want to see a whole video just dedicated to preliminary/qualifying exams. But once you've finished that, you're what's considered ABD, all but dissertation, which means that at that point, all that you have left to do is finish your research and write and defend your dissertation. So at this point, you've done your classes, you probably had some rotations where you did work in a few different labs, and now you're centralized in one lab doing a core project. Now, the difference in research for your PhD versus a master's is quite different. So with a master's, it's gonna be more than what you would normally do, for example, like in a lab in school, and you're trying to answer a specific scientific question, but it's, maybe at most you're gonna be tackling part of a paper or maybe one paper's worth of experiments. Whereas in a PhD, you're probably churning out data that's enough for 2 to 3 papers plus some co-authorships. Like, it's a lot bigger and more comprehensive of a, a topic that you're going to be covering. And along with that, there's also other differences. We've talked in previous videos about when you do a PhD, how you're going to be kind of torn down and then rebuilt back up. And to some degree that happens with a master's, but not quite the same way as when you're doing a PhD. So a PhD, you're really not just learning the scientific method, but they really rewire your brain to think in a different, more critical way, where you don't get that same level of detail when you're doing a master's. Now, PhDs are going to take varying levels, somewhere between 4 and 7 years. I would say 4 years is a really fast PhD, 7 is pretty slow. You're probably in the middle at 5 or 6 is going to be most people. That sounds about right to me. Now, once you finish your PhD, what are your options? Well, the very traditional ways to do a postdoc. There's other things you could do as well. You could go right into government, for example. You could go work at a scientific journal and be an editor. So for example, if you submit a journal article to Cell Press, it has to go through an editor that's going to screen them, decide if it's worth sending out to peer reviewers, and they kind of oversee the development of that paper. You know, they need PhDs for that. You could go into contracting. You could go into the NIH or the DoD, the Department of Defense needs scientists. There's, you know, a lot of different areas that need scientists. So there's a lot that you could do with it. Now, for those that don't go directly into those areas, the very traditional path is to do a postdoc. This is what the overwhelming majority of people do. After they're done with their degrees, they do a postdoc. So what is a postdoc? You could think of a postdoc as continued mentoring. It's basically where you continue learning, but while you're learning, you actually have, you know, some level of overview from somebody that has experience. So I say someone that has experience, and we'll get into that in a moment. So there's really two kinds of postdocs. There's an academic postdoc and there's an industry postdoc. And in a video coming up, I'm actually going to talk about the differences between the two and why you may want to choose one or the other. But if you do an academic postdoc, you're obviously going to be working with somebody that's a PI, they're a professor. And if you go to an industry postdoc, you're going to be working with some scientist or director that, you know, is in industry. And so you're going to be learning two different skill sets. One is for academia, one is for industry. Now, that's not to say that you can't switch. So like myself, I did an academic postdoc and then went to industry. You know, a lot of people do that actually. So it's not like you can't switch, but you know, those are the two different types. Now, what you're really doing is you're learning how to use the skills that you learned in your PhD under the supervision of someone else. So let's take an academic postdoc, for example. You've gotten your PhD, you really have a decent grasp on the scientific method and some of these basic techniques that you may want to use and how to develop a project. But what you need to do is you need to, you know, basically practice with training wheels before the training wheels get taken off. So before you could be a PI yourself and be writing grants and running a lab, you need to practice. So what you do is you go into a postdoc and that's what you do. You practice grant writing, manuscript writing, developing a new project, overseeing the growth of that project, not just for one paper, but what would be the next 10 to 20 years of that project. And you practice doing all of this. And if you have a PI that is really good, what they do is they gradually will give you more autonomy. So they'll first start taking over your work as if you were a grad student, where they're, you know, fairly hands-on, and by the end, they should be fairly hands-off and letting you make most of the decisions for your own career because, you know, they've trained you well. So it's a period of mentored science. And it's a really, really important part of your career, and something that a lot of people, they do it and they just say, oh, I just want to get it done, but it's really important. This is really going to form the basis of how well you can do science, to be honest. You really learn the most critical thinking and lab skills during your postdoc. So it's not something you should take lightly. You should really take your postdoc seriously. Then after that, you could go on to what would be your next position. So if you want to stay in academia, you can. You could try to become a PI, a principal investigator, someone that runs a lab, and you could, you know, be a professor, or you would be an assistant professor, but you could try to get a professorship somewhere. Now, if you're at a research institute, your main role is going to be securing grants and running a lab. But you could also be, an assistant professor at a teaching school. So a school that's not really focused on research, but it's more has a focus on education, where you're mostly just teaching classes. You can go into industry and you could work as a scientist in industry. You could go to the FDA, you could go to a whole bunch of different places. But that's really the gist of the scientific journey. So from undergrad into either, working or doing a master's, or what's the difference between a master's and a PhD, and then into a postdoc, and then further. These are some of the different options that are out there. And if anyone wants, you could leave a comment below. We could actually spend an entire video or multiple videos going over specific career paths after doing your PhD or postdoc, because there's actually a lot out there. The majority of people, yes, are gonna probably end up doing academia or industry. That is by far the most common paths that you're gonna take, and probably, I would assume, make up at least 80% of PhDs out there. But there's still a good chunk of people that do other things. So let me know again down in the comments if that's something else that you wanna see. With that, I'll catch you guys in the next one. Bye.